Okay, it is 3:30. Henry, if you could turn your microphone off, until, sorry, your video off, unless you're speaking, that'd be appreciated. Let's go ahead and get started. This is HTTP. We have 2 sessions this week, both of 2 hours. We have a relatively full agenda, so we're going to try and keep it on time if at all possible. I'd like to introduce my floating head co-chair, Tommy Pauly. Tommy, take a bow. First of all, first and foremost, the Note Well policy. You should all be familiar with this by now, but if not, these are the policies under which we participate in the IETF regarding things like intellectual property and privacy and harassment, code of conduct, copyright. There are many different aspects to it, so if you're not familiar with them, please do familiarize yourself with it. It's important, we take it seriously, and you can find it by just searching in your favorite internet search engine for IETF Note Well. Wait, any waste users here? You may have trouble, but otherwise, IETF Note Well. Next up, this meeting does have a mask policy. I'm hoping you're aware of that by now too. If you're not speaking or eating or drinking, please do wear a mask and exercise common sense. And yes, I did notice that someone left their power cord here. Hi, Lucas. Well, I didn't want to name names. So please do remember to keep your mask on, and if someone gently reminds you, take it in the spirit which it was intended. Can we have a scribe for this session? Is anyone willing to take minutes? Please. Anyone in the room? There are some familiar faces that I could call on, but they have done it many times in the past. So new faces would be much appreciated. Oh, thank you very much. And that's Jonathan, isn't it? I don't have my glasses on, but I know it's Jonathan. If you could just take notes in the, what do we call them now? I think it's a hedge doc. It should be linked from the top of the agenda.
Yeah, notes.org. And I already filled out the agenda there, so you should just be able to fill it.
Oh, thank you. Thank you. And if folks could help Jonathan out, that would be much appreciated so that it's not falling just on his shoulders. So the agenda for today. Yes, I learned about dynamic backgrounds in Keynote this week. So, excuse me, today we've got signatures, alternative services where we have a reasonably large amount of time reserved, Origin H3, a brief update, cookies, and then client certs. Now, we've had a request to rearrange so that partition cookies can be after the cookies discussion, just to keep us on topic there. If no one's having trouble with that, we'll do that. So we'll do cookies, then partition cookies, then go back to client certs. And then finally, we'll end up with an update from our friends and the enthusiasts over in the Mask Working Group. They are very enthusiastic. If you can, I don't think you can see that on camera, but there's already enthusiasm. And then on Friday, we'll go over the agenda for that then, but we have a similar kind of lineup. So like I said, very packed. Any agenda bashing beyond what we already heard? Okay, let's go ahead and get started then with the signatures discussion. And I'm going to see how far I can take this just projecting my entire screen. Take it away.
All right, hi everybody, I'm Justin Richer. This is going to be a short presentation, next slide please, on update on HTTP message signatures. We've gone through a couple of revisions of editorial updates, added more examples. We added something called the tag parameter, which was very briefly called the context parameter until we got some feedback that that was a dumb name. And so there's a tag parameter in there now. It's optional, don't need to get into it. And we have gone through a 1-month-long working group last call, after which a lot of comments came in about the document. So thank you for those that that have done that so far. Right now, there are only a couple of small things going in. So first, Lucas needs to apparently get me an update on the digest example in the draft, I think. Thank you. I guess apparently it's wrong. I'm not sure how it's wrong, but if you could make it not wrong, that'd be awesome. And we can touch base in the hallway or something if that's easy to do. Next slide though. but there is an open question about what do we do with trailers? Can the fields that we've defined, can they be trailers? Currently they're allowed, but do we need to be more specific about what that means when they're trailers? And can we sign trailers? And if we do so, there's a couple of things that we could do. Right now, everything is just sort of defined as fields, and we kind of mash them all into the same namespace, which is what I thought we were allowed to do. But somebody pointed at a line in HTTP semantics, and I'm getting some head shakes in the room. So this might be a very short discussion. Next slide, please. So obviously, if we have a hypothetical field that can exist as both a header and a trailer, do we both call these both food? Next slide, because the naive thing to do would be to just cram them together to look like this. That's what the spec says to do right now. I'm getting a lot of head shakes. This is why I tagged you guys on the GitHub issue, so I wouldn't have to have these slides, but I'm glad we're here. So next slide, the alternative proposal is to just explicitly call something out as a trailer, as a data source, using a Boolean flag that tells this, that allows the signer to signal and the verifier to know where to source the information, and then otherwise we just treat it like any other field. Next slide. We actually have precedent for this with the request parameter that's already in there. When you're signing a response, you can get the related request information and pull it in there. And so I think I already have the answer, but let's go to the queue.
I'll interject, and then Martin might have something to say. So in HTTP, the most recent series of updates, we recognized that trailers had some really fundamental interoperability and deployability issues, and so we defined them as a separate namespace from headers. So they are distinct. You cannot just naively combine them unless the definition of the header field, or sorry, the field, says, yes, you may do that.
Oh gosh.
And so we flipped that. So your approach, the approach that you talk about here with using TR might be workable.
Mm-hmm.
The only thing that I would add to that is that you have to realize that it is completely legal to drop trailers on the floor, both in intermediaries and by recipients. They can just disappear. And so you need to account for that if you want it to be robust.
Yeah, we definitely need additional implementation considerations for trailers. In that case, I think there's already some text in there, but it needs to be more robust for sure.
I mean, you might even consider, if it appears, it should look like this kind of semantic.
Mm-hmm.
Yeah. Martin Thompson.
Goodness, you wouldn't want to be short. Martin Thompson, presumably you can add both TR and rec to the same field name in
Correct.
the case that it's a trailer on a request. This
Can you do that?
Yes.
Okay.
Then
yes.
Theory?
Right. So that's if I want to ask you too, but if you go back to like several slides, my final question on trailers is, are they even real? Because I actually found that in some of the libraries I was using, I can't get to trailers.
Oh yeah, this is a common complaint. So they are real. They're probably not a great thing to be signing for the reasons that Mark stated, but
Yep,
they do
for sure.
exist, and it sounds like you're trying to get everything. So
Yeah,
it seems to work.
Yeah, I can't see a compelling reason to disallow it. So I would rather have it be very explicit, like if you're doing it, this is what it is, and these are the problems you're going to run into.
Right.
This is a great way to make stuff break if you sign these things, but that's what people want sometimes, I guess.
Yeah.
The observation I'd make is that the people who do use trailers tend to really like them, and they tend to do weird things. And so it wouldn't be out of the question for them to want to do a weird thing with signing them.
Right, exactly. And this is definitely off in corner space somewhere, but we wanted to make sure that it was covered. So anyway, thank you. I will put in a PR to add the TR flag with a definition for that and toss that around. But yeah, apart from tweaking a couple of examples here and there, the working group last call feedback so far has been pretty positive. And I've also been discovering a handful of more implementations out there in the wild, which next slide. I'm going to be talking about that a little bit at the SAG on Friday morning this week, where I'm basically going to be presenting what the draft is and how it works, and very, very briefly to the wider security community, and then tell them to come at it with pitchforks and pickaxes and whatever else they can get on hand. And basically help us figure out, like, did we leave security holes in here that we don't know about? Are there weird Oracle attacks or gotchas or other things that that are hiding in this space? So it's going to be exciting time after that, I'm sure. The second bullet, which I'm pointing over here now. The second bullet is that if you have an implementation, or you know of an implementation of the HTTP working group draft, not the Cabbage draft, I'm going to be putting up a tab on httpsig.org, our sort of demo site playground space, to start listing these implementations, because I've had a lot of people coming at me lately asking for that list. So I'm going to put it up and then just have a link to, like, make a GitHub pull request if you want to add your own. But, you know, get in touch with me. I'm seeing more and more out there. And I think that's all I had.
Great. Any questions, feedback? Okay, thank you, Justin.
All right, thank you.
And if folks are able to attend SAG, it conflicts with us on Friday, but if you happen to be there, that's a good conversation to watch, because there's an open question about what the appropriate level of review is for this kind of really pivotal spec.
They're presenting on that just before the formal review process, just before I did my signature stuff.
Great, and if you could do us the favor of maybe reporting back on the email list or something, that'd be great. Next up, alternative services. Mike. Great.
I'll skip over the joke that inspired the picture there, but slide. So we have all this nice complicated infrastructure of how we handle the user's request and where it flows through.
I don't know where that comes from.
All right. But slide. What we're trying to handle is when the user accidentally winds up over there, where we'd really like to get them on the red path that we had planned for them, and we want to redirect them a little bit. So slide. There are a couple of cases where that happens that we'd like to make sure that we handle. One of the most common ones is when the DNS resolver is not near to the client, and for privacy reasons or otherwise does not pass along the client subnet in EDNS 0. There's also, for those CDNs that use Anycast can wind up in the wrong spot. It happens. There's a lot of work that goes on to make sure that doesn't happen, but it still does. And in some cases, we have endpoints that can offer you better service based on where you are or who you are that we didn't know when you did the DNS resolution. So we might like to be able to point you to some endpoint that we control that's special that would give you faster service. And the most common use of alt service right now is for protocol availability. So you spoke to us over H2. We'd like to tell you that we also have our H3 endpoint, or you spoke to us over H1 and we'd like to tell you that H2 is at a different port, hypothetically, although that mostly doesn't happen in the real world.
We've got Julian in queue. Julian, do you have a question of clarification, or can it wait to the end?
I wanted to mention that apparently the chat doesn't work. Oh, no, it actually works. So I had actually questions for Justin early on, but the messages didn't come through. So
Sorry,
apparently, no.
Questions for Justin.
So
Yeah.
the news is that Zulip is down for most of things, so all the chat is busted. And so Julian's got some sort of low priority questions that he can't get answered. There's an IETF.
But it seems to be up now.
Oh, okay, it's back again. So
Okay.
Yeah.
false alarm.
Sorry.
So perhaps that's a request for you to go into Zulip and field some questions. Okay.
Okay. Sorry, continue.
Okay, slide. All right, so we at this point have two main ways to redirect the user. We can either do it before the request happens using DNS, or we can do it after the request happens using alt service. And those are both great options. Slide. Trouble comes when we have to combine them. Right now, what the service B spec says is that if you implement alt service and HTTPS, you take all the host names you found in alt service, look up HTTPS records for all of those, then filter down to everything that's consistent with both the HTTPS records and the alt service record, and then attempt to connect to whatever's left from that combination, which produces some confusing results. Notably, there's only one resolution here that is even in the original origins domain. Yeah. You can set this up, but it gets a little confusing, and we're trying to define a better coexistence story moving forward. And so the simpler version, slide, and delay. Oh, okay. So the trouble that we have, other than just using them together, is what do we do when we get both sets of information? Because the alt service is potentially old, so how do we make sure it's still valid? But it was received over a TLS connection directly from the origin, whereas DNS comes through other servers along the way, possibly unencrypted. How much do we trust when they don't say exactly the same thing? So we want a way that lets us make sure things are fresh before we use it. One of the concerns that we've heard is an alt service that says, you can come talk to me over H3, but when you re-resolve the host name, you get pointed to a different CDN that doesn't support H3, and your connect fails and you time out, which is not great. Next slide. So the draft that's been submitted just before the deadline was to replace it with very close to the straw man that we had talked about last IETF, which is this alt service B, which provides you a host name that you should go resolve. Slide for the semantics. Slide. Or, okay. It's just lag. So basically, right now, the first step of it is ignore any legacy alt service that's there. So that helps avoid any of the collisions that we might care about. Just do an HTTPS lookup for the host name, do all the service B required connection stuff that's in the HTTPS spec, and use that connection instead of this one. So we're trying to move you over to a different endpoint now. And then in the future, remember what endpoint you wound up on and give that some preference when you do future HTTPS resolutions connecting to this origin. If you don't see that endpoint, oh well, you just go on with what DNS says and you forget it. The next slide. And this does leave us in a little bit of a situation around stickiness, which is that if you're not remembering, or if you don't have that endpoint in the DNS all the time, then you're going to go to origin, get redirected with alt service. The next time around, you go back to the origin, and it'll tell you to go over to the alternative again. So you might wind up flip-flopping unless you put all of your possible endpoints in the DNS. Some providers don't want to do that because they don't want to enumerate all possible endpoints in the DNS. But if you remember it too long, then you override the ability of a site to do multi-CDN or otherwise change where they're pointing you. So this is a trade-off that we're going to have to make. Now, we had a long conversation about this at the HTTP workshop. Slide. And we had, over the course of that long conversation, we basically redesigned the proposal and then wound up right back at the proposal that was submitted because everything else we tried didn't really work out or had some conceptual difficulty that made us drop it. So where we wound up with is DNS is always reasonably current for the time that you look it up, probably have short TTLs. That's where CDN load balancing happens. It always gives you the endpoints of or the properties of the endpoint that you're actually talking to. So we always want DNS to have more or less exclusive real-time control over who you talk to and what you should expect to do on that connection. And alt service is more interesting for once you get to that origin, if it wants to move you to a different node, so distributed origin, CDN, whatever, it's mostly interesting for redirection in real time, and stickiness may not be as much of a concern as it originally was for alt service or as we thought it might be. So I think at this point, we're just going to open up for discussion on the draft that was submitted, the current alt service BIS, and how we want to move forward with this. And I see Martin getting his phone to get in the queue. I also see Ben.
Ben, you beat Martin. Go for it.
Hi, Ben Schwartz. This all sounds like a good improvement to me. I'm for it. I don't understand the stickiness. Where did you end up on stickiness?
Stickiness.
So the issue about stickiness is how does the client verify that the information it has cached is still valid for an alt service that potentially has a very long lifetime? So you have conflicting, we would like to have a long lifetime on the alt service advertisement because we want you to remember what protocol to use, especially if it's at a different endpoint, when you come back on a future connection. But on the other hand, load balancing happens at a much shorter time scale, so we don't want you to remember. So we want some amount of stickiness, but we want DNS to be able to clear it or override it at the time of your next connection. And it's trying to strike the right balance of that that's difficult right now.
Okay. Yeah, I think that it's perfectly reasonable to say that the alt service B is a sticky indicator of which of the alt hosts or which of the alt RRs is preferred, and that its lifetime is the and that it applies after DNS resolution. So on some, a week from now, I want to connect, I re-resolve the name, I get an RR set, and then I check it against my sticky host name. And if the sticky host name is in that RR set, then the hint applies, otherwise it's discarded. I think that gets you what you want.
Right, and the current draft as submitted actually has a flag that you can put on an RR set or on a record that says never use this alternative unless you were explicitly told to.
Yeah. One thing that I wonder about here is, should we just make this stickiness thing a general property of the HTTPS record of service bindings? Like, you gotta, you tried various service bindings in the past and you found that one of them was the one that actually worked. Like, do you really have to try them in priority order next time, since you know that the other ones didn't work and this one did, or your selection algorithm selected this one last time?
So from the discussion at the workshop, that is actually something that certain clients do. I don't know that we need to specify that per se.
Right. It just seems like you could effectively just say, this is just a special case of that.
Yeah.
Okay, that's enough.
Thanks. Martin.
Yeah, so I wanted to make clear here that the proposal from the design team that's been working on this alt service thing is effectively to take this or something approximating this as the complete replacement for alt service. So the draft proposes that I think that I've got to use the right words now, obsolete, not deprecate, is that right? We obsolete 7838. And that seems to be the general sense that I've gotten in discussions, is we want to effectively say that alt service is no longer useful.
Mm.
There are some suggestions on how we might improve things. There are a number of open questions that we have. Mike probably didn't touch on all of them. The more interesting ones for me is HTTPS records have priority order. That gives you some control over where people end up. And you can always put these alternatives that you don't want people to use as the primary entry point to your service down the priority list on your HTTPS RR sets that you return. But maybe that's not definitive enough. So we also defined an attribute on each one of them that says don't use this unless it's an alternative that you've been told to use explicitly. Those two mechanisms both provide you with some amount of control over the use of an alternative. We're not sure if we need those things. Someone on GitHub has actually proposed that we have an alternative way of spelling the stickiness, which I think would be quite interesting. I've asked them to post it to the mailing list, and if they don't, I will, because I think it's an interesting idea. But we're sort of trying to get a sense of the general shape of this thing to see if people are interested in, does this solve your problems? We've heard from a number of people that simply deprecating alt service and relying more on HTTPS records solves their problems adequately, and they don't necessarily need this thing. We've heard from others that they like the idea of being able to steer traffic using the alt service records, the alt service advertisement as we've defined. So that's the sort of feedback we're looking for here.
So just to be clear, the potential path forward then is, once we get enough comfort around this, to stop work on alt service BIS and to adopt this new draft. Correct?
That would be the idea, but I think at this point we're just putting this in front of people.
We're not quite ready for that
time
yet.
to think about it,
Right.
but and also recognize that there's a few things that we need some input on as well.
But it does sound like we probably should park alt service BIS until we know.
Yeah, the alternate spelling of that is to incorporate the new draft into alt service BIS.
There are lots of ways we can do this. Sure. Yeah. Eric.
Eric Kinnear, Apple. So I just wanted to reiterate a little bit, and you were saying, is this useful for people? And so I thought I could say, heck yes, it is. So we strongly prefer getting this kind of information from DNS. It's much nicer because it's for the place that you're actually going. And it's something, most importantly, that you know upfront at the time that you're going. So rather than saying for next time, you can say for this time. And that has been shown, I think, via some data that was presented to the previous IETF, that makes a significant and measurable difference in the amount of H3 that we actually use. So that much is awesome. Being able to take HTTPS records and say these are lower priority and have a separate signal for do not use this unless house is on fire. Both of those signals, I think, we find are super useful, and we have a number of people where we are asking them to do that, and they say we do not have a mechanism, so we can't do that. So if this gives them that mechanism, then like both of those unique signals are awesome, and yes, please. And then beyond that, yeah, we can go into the rest of what's left for alt service after we've moved that out. But I just want to say we do very much have a need for that, and we would be shipping it yesterday if we had it.
It probably is important to note that at least at 114, we did have some people saying they didn't want the ability to indicate H3 with a header to go away entirely. So that may just be solved by, okay, you can use the obsolete thing if you really have to. But it's important for us to remember that some people do still need that affordance for a little while.
It's a question what the time scales are. And
Yeah, David Skenazy, that's pretty much exactly what I was going to say. And just to explain that, Chrome and other web browsers today don't always have access to the HTTPS record, because like Apple platforms are awesome and they have good APIs. But if you look at POSIX cross-platform, get_info gives you pretty much what existed at the time. So realistically speaking, in some platforms where Chrome has its own DNS resolver, everything's fine. I know there's some people at IETF weeping that the applications are all bundling their DNS resolvers now, but for cases where we don't, we'll still need to use the old thing. I don't love that we're obsoleting the old thing because it's still useful, but at the end of the day, it doesn't really matter. As long as we're all on the same page that we might still make changes to alt service if we have a reason to, then everyone's good. So like MT was saying, we can obsolete it, but we're not deprecating it, and that seems fine. I forget what all those words mean anyway.
Tommy.
All right. This is a question for David if he's still up. I think there was
Tommy.
some comment on the list around when are we going to update POSIX get attr info? I don't think that function signature is going to change at any point soon. Just to confirm, I imagine people would probably be okay with a separate function in some standard DNS library because get attr info already probably is coupling too much of the A and quad A queries synchronously, and so your SVCB lookups should be separate anyway. So would it be sufficient on any given platform to have a somewhat bespoke DNS API for these things?
Well, David Skenazy, happy eyeballs enthusiast. Yeah, like in practice, it's a matter of time at the end of the day, and resources. Chrome today has all the energy. We don't have a huge networking team as we used to, and so the energy goes into the client DNS. I don't work on Chrome anymore. The energy is going onto the DNS resolver that is bundled with Chrome, and the cross-platform fallback uses get attr info and pretty much is not going to see any love, probably, unless it becomes a pressing issue. So given infinite time, totally we'll do it. It makes sense. It's possible, but it's in practical things. There's always another shiny API, web API to do instead. But just to clarify, I think the goal is to ship the Chrome Zone resolver on all platforms, and that kind of makes this go away. Just it turns out to be trickier than expected. So I think at some point we'll get there, and this becomes a non-issue, at least for Chrome. I don't know what Firefox is doing when they're not using Doe.
Lucas.
Hello, Lucas Pardew, Cloudflare. Sorry, I didn't use the tool. My phone ran out. No recovery from that. So as somebody responsible for advertising H3 and wanting to work and being involved in the design team, I support the shape of the solution that we've got. As Martin said, that the suggestion on GitHub the other day is kind of interesting. Be willing to see where that goes or doesn't. But I really like this because I don't have to do anything. I would support this because the clients need to do some things and change stuff, and we already do HBS records, and it would all kind of work very straightforwardly. But I'm not in a humongous rush to remove the alt service header tomorrow or whenever. We can leave it there, and it has a place. For me, the important signal here is for people who are suffering now with the problems of the alt service header and are asking us to try and find solutions around it, and having the IETF give them a clear signal that this is not the path to be explored for future solutions, but it's not a dead end either, in the sense that it's going to be turned off and we're never going to speak anything, and you're just going to be left in limbo with no way to use H3. That's not what we want. We just want to make it clear what the future is in our mind, and that date can just come in the future whenever it is.
Yeah. So Martin Thompson, I find it funny sometimes when we're talking about lack of engineering resources at Chrome, when it's often the other way around. But I think that's a transient problem. I think probably the more pressing one is the availability of HTTPS records and how able you are to make a query for them. We've done some research that hopefully will be published relatively soon that talks about the success rates for different types of DNS records. And off the top of my head, I can't remember the exact numbers, but it was something in the order of sort of 2% for A's and quad A's, 5% for HTTPS failed. It was more like 45% for DNSSEC related records, for those who are curious about those sorts of things. So that to me speaks to having some amount of HTTPS, alt service legacy style around. It may be that we want to encourage people to start shortening their max age on that, so we get something closer to this sort of behavior from the systems, and we don't run into the sort of two caches problem that was a major issue with alt service in the first place. That said, I think this really hinges on like how much HTTP3 you're willing to sacrifice to the altar of just making progress. I think probably at the moment for those people who are, maybe strapped for engineering resources, this is possibly, too much HTTP3 to leave on unrealized. But there may be a point in the future where we can sort of say, well, that sort of incremental, 3 or 2 or 3% of networks that don't pass HTTPS records, just they get the H2, and that's okay. But that's a discussion we'll have to have later.
Any more slides?
Nope.
Okay. All right. So it sounds like we've made some pretty good progress. Still need to do a little more work and a little more socialization, maybe. So I think we'll continue to leave the alt service BIS document part.
Yep.
'Cause that's
Please read the
effectively-
draft, provide comments.
Yeah, continue to work on that, and then we'll get to a point where we need to do a call for adoption if we think we're right for it.
Okay.
Yeah. And figure out the disposition of all the other pieces at the same time. Yeah, yeah. Any other questions, comments for Mike? Okay.
All right.
Thank you very much, Mike. That was very productive. And
I'm also the next speaker.
and you've got a little extra time too.
Okay.
So next up, Origin H3, which I believe is this one. Yes. Once again.
Okay. So this is the origin frame that we had in H2, recast in H3. However much you like it or you don't, that's where we are. So first we should recap all of the semantic changes from H2. There they are. Review them carefully. Next. So structural changes, stream 0 is a request stream in H3, so we have control streams, so we have to map those terms. And then Lucas filed an issue that we hadn't caught previously, that H2 has flags. H3 does not have flags. So here's what the original origin spec has to say about flags. Next slide. Which is, we don't use them, but we might in the future. So then there are 4 flags that are mandatory to understand. If the flag is set and you don't know what it means, ignore the frame. The other flags are not mandatory to understand. If they're set and you don't know what they mean, shrug and move on. Keep using the frame as you understand it. So we have those. In H3, we would have no way to set them if we ever did define them in the future. Next slide. So what do we do about that? We could take the very simple path of deprecate flag usage from H2 and say we haven't needed them so far, we're not going to. We could not say anything and fix the problem if we need to down the line, although that could be kind of awkward if we decide to retrofit them into H3 later. We can stick an always 0 byte in the frame, which makes me a little sad, but it's 1 byte. Or we can stick an optionally present flags byte on the end, and if it is all 0, you may omit it. None of these seem fantastic. All of them will work. Opinions, and then let's move on.
Okay. Martin Thompson, before we go on, I'm just going to note the very nice options pun on this slide. Well done.
Yeah. So we have mandatory flags. Turns out mandatory flags are just called frame types, so we don't have that problem. If you want to define a flag that's mandatory to understand, pick another frame type, and off you go. So problem solved there. The optional ones are optional, in which case we can solve that problem later when someone wants to define one of those flags. And we might do it in any number of ways, by defining new frame types or by defining this stupid hack thing with the bit at the end that you cut off if it's not there. I think these are problems best solved by future us, who I predict will probably never actually care to solve them anyway.
David?
David Skenazy. Similar to MT, I think, yeah, we have a 4th option, which is kick the can down the road. we're not painting ourselves into a corner, because if we need it, the correct thing is the frame types. We have one extension joint that we should grease well. We don't need 17 of them.
Mhm.
So just say we don't use them, done.
Okay.
And sure, maybe I wouldn't even bother deprecating them from H2. Like, just don't use them, done.
Don't accommodate. Lucas.
Lucas Pardew. Yeah, sorry, I created the issue and I didn't think of any solutions for it. Sorry. I forgot I'd opened it, but it was in a fit of late night spec reviewing. Yeah, I don't like any of those options. I don't think we should change H2 at all. So I agree with David there. Adding bytes and stuff just seems weird. I don't. This is a lot of the time with H2 and H3, we're trying to mitigate kind of proxies that might pass through frames.
Mhm.
Even though you're not passing frames through, you're reconstituting them from their parts, kind of thing. Origin is a bit of an odd one. I don't think there's anyone kind of passing origin across multiple proxies like that. Like, I don't think we know enough about the problem to be able to design anything that would make sense and not complicate stuff for no good use. So if we wanted to find 4 frame types that just basically all know up, so it's just these are all the types for origin in H3 and they're all the same. That seems fine. It's no harder to write that code than for one type.
Do you think we need to define those frame types now, or just leave ourselves the possibility to define them in the future?
I don't know. I have no strong opinion. I'd had a weird idea a few years ago about maybe a use for one of the flags in the H2 frame. So maybe, but without a concrete use case, like punting on it would be fine.
Hmm.
We're not short of space for frame types.
I'll just give my own feedback. To me, the clearly worst option here is the last one for the reason you point out.
Mhm.
It is not worth doing that to save 1 byte.
Okay.
But it sounds like we might be converging on kicking it down the road,
Mhm.
giving the problem to a future us, and closing the issue with no action, I think is the outcome.
Which I think is a fine solution.
I'm seeing thumbs up. Is it worth a hum? I don't know. I
Um,
haven't done a hum for so long, you know.
uh-huh.
Or sorry, just or a slight
Show
tweak.
of
No,
hands.
Damn it. Never mind.
I will point out that in terms of actual structure of the frame, reserving multiple frame types to account for all the flags is exactly the same as sticking 1 extra byte in. In fact, it's slightly worse because of the varant and the 2 bits for that.
But you're saying actively reserving them, not just kicking it down the road.
Correct. If we were to reserve them, then we might as well just stick a byte in. If we're kicking it down the road, then we don't worry about it. We don't discuss that part of the spec.
One more question. Does anybody really care about this?
No. All right.
Okay. That's all you got?
I will go close the issue. So the remaining question, which is implied by the picture, are we at the finish line? Working group last call? All right.
I see nodding heads and thumbs up.
All right.
Yes.
Thank you.
Thank you. Okay, we're doing pretty well on time. Next up, cookies. And how long did we reserve for this? I think we're going to talk for 15 minutes at most. Awesome.
Hello all, my name's Stephen Bingler, Google, Chrome, and I'll be going over a status update for 6265-BIS. For anybody who was present at the last interim meeting, these slides are going to seem very familiar. Next slide, please. There hasn't been a new draft since, actually that's not true as of about 5 minutes ago when we just pushed a new draft, but I'm going to talk as if we didn't do that. There hasn't been a new draft since IETF 114. So all these changes are since that previous draft. During previous meetings, I've stood here and read through all those bullet points, and that felt stilted and weird. So instead, I'm going to leave them on the screen for a few moments. And if anybody has any questions, I can go into more detail about them later. Next slide. One moment, 2 moments. Next slide. Let's see. There's only one change here that's actually worth talking about. Just landed one where cookie prefix names are now checked case insensitively. Previously, they were checked sensitively, meaning that you had to get the exact case for the guarantees for cookie prefixes to be applied. These are the __ secure and __ host dash cookies. But it turns out that servers don't always check cookies case sensitively because of course they don't. So servers were setting prefixes without realizing that they weren't getting any of the guarantees from browsers, and that's bad. So we fixed that. Next slide. We have 3 open issues currently. Same site cookies and redirects. Quick recap on this. There was a bug in the original spec where same site did not take the redirect chain into account. So if you redirected from site A through site B and back to site A, we would consider that same site and happily send you your same site cookies. That's wrong. The spec was fixed, but when Chrome tried to launch this or enable this feature, we got a ton of complaints and there was a lot of site breakage. So we disabled it and currently trying to figure out next steps. We're collecting metrics on how sites are using this behavior to try to get a better idea of what to do with it. But with the US holiday season approaching, I'm expecting we're not going to get anything useful until until Q1. The other 2 open issues, internal whitespace and cookie names and values. This was recently filed. Turns out that the 3 major browsers, Chrome, Firefox, and Safari, all handle internal tabs somewhat differently. Internal tab being that you have some other non-tab characters, a tab, more non-tab characters. The spec was modified somewhat recently to disallow control characters, but it accepted tab characters. What this means is that now the spec says you should accept those internal tabs, but not all browsers do. So I'm trying to figure out if that change to the spec should have happened and whether we should revert it. Final one is a mouthful. The spec should more clearly advise which parts a reader should implement. I filed this one because we've had a number of issues with implementers implementing the wrong requirements because they are confused on what they should do. And I can't exactly blame them. It's not an easy document to read. So this is kind of a task for myself to go through and write some prose that makes it a little bit simpler for someone to know what they need to implement. All right, next slide, please. So we've already have some work planned post RFC 6265-BIS. The first is cookies having independent partition state. Dylan will be up here in a few minutes to talk in more detail about that. The second one is cookie spec layering. Originally, Johann Hoffman was going to speak on that. Unfortunately, he was unable to make it, so I'm going to say a few words about it. I'm hitting things on my computer here. So, cookie layering is an effort being headed by Johann Hoffman and Anna van Kesteren. The idea is that the cookie spec has kind of intermingled itself with the browser specs, with same site and partition cookies and blocking. And this is an effort to sort of decouple the cookie spec from things that could be better handled by, say, the fetch spec. Let's see. This was brought up during TPAC as like an initial idea and request for feedback, and seems somewhat positive, but there's a lot of work ahead for it. That is all that I have. Do we have any questions?
So I think the idea here is you want to close those 3 issues, go through working group last call, go through the IETF, ISGQ publication process, and then we'll talk about starting almost an immediate revision again to address your deferred issues and these work items. Is that kind of?
Yes, that's correct. Once the 3 open issues are closed, I'm hoping to go into last call.
Okay. And the cookie spec layering, I know that there's been some background discussion about that. I think that's, we've for a long time talked about how to make the cookie spec more extensible, more user-friendly. I think we want to try and involve non-browser communities as well to see where the right line is to draw about making that separation. But that's a discussion we can have. I think that's very reasonable. David Skenazy.
Hi, I'm failing to find the issue, but I remember there being some discussion on the topic of UTF-8 characters and just allowed characters in general, about how the spec allows a different set for setting cookies than for sending them. And like, I think April King found some issues there that were even somewhat worrisome from a security perspective. Where did that discussion go? I just couldn't find it, sorry.
That discussion happened in a pull request rather than an issue.
That's why.
I spoke with April just face to face, and we decided that at the moment, okay, so context. April has found a number of issues where browsers will send and save cookies that servers then won't accept. This is a problem primarily because nowadays a server is not a single entity. Companies will have SaaS products that they use that will send cookies, but then their Python framework or PHP or whatever won't accept back the same cookie that origin sent out, which when the spec was developed, I assume the authors thought that, oh, if a server is going to send something, it can obviously understand it when it gets it back. After talking with April, we decided that simply changing the spec to say that, oh, hey, servers should accept this expanded character set was not the correct route. I think there is, no, I know there's a deferred issue for the next version of the spec where we are going to more formally look into allowing expanded character sets and kind of what the effect that's going to have. But at the moment, the plan is to keep the status quo.
Thanks, that's reasonable. MT and I are working on an active protocol maintenance document that talks about these considerations. So having the spec match reality is important. Maybe if, I don't want to volunteer you for work, but if we could have like a paragraph explaining that there's a foot gun in the spec, that might be useful. Just, as a warning, note that this is different from this and here be dragons might be good.
Yeah, that's exactly what that final long-winded issue that I filed is, was just like make it easier. Yes, thank you. Oh, highlighting.
Oh. Perfect. Thank you.
That's exactly what that's supposed to be.
Yeah, that's been kind of an ongoing theme for a little while, so it's good to see that addressed. Yeah. All right. Should we go into partition cookies then? Yeah.
All right. Thank you all.
Thank you.
Hello, everyone. My name is Dylan Cutler. I am also on Google Chrome, and I will be discussing partition cookies with you guys today. Slide. So just a quick overview. So when we say a cookie is partitioned as opposed to unpartitioned, what we mean is that when a cookie is when an unpartitioned cookie is set in a third-party context, it is available on essentially any top-level domain that makes requests to the domain that set the cookie. And by partition cookies, we mean that these third-party cookies would only be available on the top-level site in which they were created. And then if the user were to navigate to a different top-level site, then the third-party site domain would receive like a brand new cookie jar. Also, just as like a forewarning, this talk is going to be like, because it's partition cookies, a little more browser heavy than some other like talks. So if that's not your thing, feel free to tune me out. Slide. So the partitioned attribute is a proposal for a new cookie attribute, which would allow sites to opt into this behavior. And just to go over the design really quickly, it would require secure domains would be allowed up to 10 kilobytes or 180 cookies per partition, and we determine how much memory a domain is using per partition by the size of the name and value of the cookies. And then another detail is that clear site data would also only clear cookies in the current partition that it was in, and this would be to prevent cross-domain entropy leaks. Essentially, there's attacks you could set up where you intentionally call clear site data on different top-level domains in order to essentially like build enough cross-site entropy to develop a like persisting cross-site identifier. Slide. So today I'm just going to be going over some of the open issues we have for partition cookies. The first one will be, how do we deal with partition cookies in what we call quote unquote unpartitioned contexts? Also, we want to discuss whether the partition key should have a field called cross-site ancestor bit. We also will discuss how to handle partitioned and unpartitioned cookies which have the same name. And then finally, we'll go over, should there be a way that user agents convey that they are sending the request from a context in which only partitioned cookies are allowed if we're in a future world where unpartitioned third-party cookies are obsoleted. Next slide. So first, we'll talk about partition cookies in unpartitioned context, and I'll start by defining what we mean by an unpartitioned context. In this case, it would mean a first-party context, and so in that case, it's a request where the top-level domain and the domain making the request, getting or setting the cookie is the same, or it would be contexts which have received a privilege essentially through user consent through something like Storage Access API, for example. One like nuance we like to point out is that Chrome and other browsers, particularly Firefox's implementation of unpartitioned contexts differ. This is kind of where the issue arises. Chrome supports both unpartitioned and partitioned cookies at the same time and uses null for the latter's partition key. Whereas in other browsers, as soon as Storage Access API is granted, the partition key for that context essentially switches that cookie's domain as if it were like kind of originating from the cookie site. And so the question is, how do we handle cookies that are set with a partitioned attribute in these contexts? Do we set the partition key to be like the current top level site, which is what we are proposing is the right answer, or do we just use like whatever the current partition key is? We think that we should just set it to be whatever like the current top level site is, even in these more privileged contexts, just because the site is including the partitioned attribute because they're opting into this behavior explicitly. And there are also ways to use cookies in these contexts without using the partitioned attribute. Next slide. Oh, and then one more note about that asterisk point. When I say like Chrome supports partitioned and unpartitioned cookies at the same time, I don't mean that Chrome will like continue supporting unpartitioned third-party cookies into the future post its third-party cookie deprecation timeline. Just want to like kind of clear the air there in case I accidentally start any fires. So moving on from there, the next thing we want to talk about is whether the partition key should have what's called a cross-site ancestor bit. And I think the best way to explain this is visually. So let's say a server is setting a partition cookie in a first-party context where the request domain and the top-level domain are the same. In this case, the cross-site ancestor bit would be false because the request is originating directly from the top-level frame. Slide, please. But in this next scenario here, we see that although the request is coming from the same site as the top level domain, there is a third-party ancestor or cross-site ancestor between the top level site and this frame or context like making this request. Next slide, please.
It takes a while.
Yeah, it's fine. So this cross-site ancestor chain bit was actually originally introduced in the W3C as part of like the storage partitioning effort, where browsers are partitioning JavaScript storage in the same way we're partitioning cookies so that they aren't accessible to sites across different top-level domains. And the reasoning behind that was like primarily to like correctly compute site for cookies in partition service workers. And effectively, by adding this bit, it would separate the partition that top level contexts get from context with a cross-site ancestor. And on the question of whether we want to add this to the cookie partition key, there's a pro, which is that there are consistent consistent partition boundaries across cookies and storage, which is nice for developers. But there are some cons. For example, this would essentially be a reimplementation of same site because developers can already restrict which cookies are accessible in and out of these contexts by setting a cookie as same site lax or strict. And then another con is that there are cookie use cases. If you want to know specifics, you can ask me after. Where the top level site and same site embed with a cross-site ancestor actually need to like communicate with each other with cookies. And so we think that adding this ancestor chain bit would be harmful. Next slide. And so the next issue I wanted to go over is how to handle partitioned and unpartitioned cookies with the same name. And it turns out there's actually already precedent for this. Domains can set cookies with the same name as long as they differ in either their domain or path attributes. And so in order to account for partition cookies, we propose adding the partition key to this tuple of attributes that we use to consider what cookies are unique. And that if a browser were to set a cookie with the same name and value, but one had the partition attribute and one would not, we would send both cookies in the cookie header in subsequent requests. Next slide. And then the last issue, how can user agents convey if a site, how can user agents convey if a request comes from a context in which the browser would only accept partition cookies? And we think that this shouldn't really be a blocker for speccing partition cookies. This is kind of a long-term question and has implications beyond like just partition cookies. And so kind of our solution for now is just punt this down the line. Next slide. So the next steps would be to continue to align with spec work with this group and also the W3C to align with things like the cookie store API or document.cookie. And also chips or cookies having independent partition state is a good example of actually how IETF might benefit from cookie layering, because essentially if cookie layering happens and we move some of these more browser specific things into the fetch spec, then really all the IETF needs to be concerned with is how user agents parse the partition token in the cookie line, and then they can kind of let the fetch spec handle the rest of the partitioning behavior. And that's it. So if anyone has any questions, feel free.
So I think from a process standpoint here, when we talked about adding major new features for 6265 BIS, we had a relatively rigorous process for getting consensus around here's a proposal with a draft. Does the community want to add that to 6265 BIS scope? And so this is probably too late for 6265 BIS, and I don't think that's a surprise to you, which is good. And the question is, when we do this next revision that we were just talking about, are we going to use a similar process? And if so, would are folks interested in taking this on as a piece of work? And as before, I think, in 6065 original as well as BIS, we kept the focus very firmly on implementer intention. And so, folks who have cookie jars, they're not the only people who matter, but they do really matter to this discussion. So that's who at least we should hear from. Martin.
Yeah, so not wearing my Mozilla hat, but the Privacy CG chair and W3C, that group has pretty broad support for this work and would very much like to see the work proceed. And I think we have agreement also that the IETF is the right place to do that because the IETF owns the cookie spec and it doesn't make any sense to put it anywhere else. I think we're willing to be guided by everyone else in terms of timelines and whatnot. And it very much seems like this cookie revision is like this close, is my impression. And I see nodding, so that's good, because I would really like to see it finished as well, as much as it's been 15 years or however long it is. So I think this is probably something that I would sort of advocate for some sort of signal that it's working in the IETF process. So I sort of would prefer if this were adopted here, perhaps parked on the side so that we can continue to work on it and refine it and answer some of the interesting questions Dylan's asking here, but not block other important work. That would be my preference here.
To me, that sounds reasonable. And I think one of the questions in my mind is, do we launch that next cookies work at Yokohama or even beforehand? But I guess that depends on a lot of different things. Okay. Any other comments, thoughts? Anyone online as well? Brian.
Maybe sort of a naive question, but can you explain a little bit more the rationale for providing this at all versus the browser just making its own decisions about how it will partition or not partition? That it's always felt to me like it's a question of how the behavior of the client itself, the browser or whatever, behaves, and putting it onto the wire and part of the cookie spec. It's hard to articulate it more than that, but
Are you referring to like the attribute and like the opt-in behavior and just say like how?
yeah,
Okay.
yeah, like at least is my understanding, like Firefox, Mozilla basically partition cookies, right? Or has the opportunity to partition cookies in their client, and they just did it. They partition them top level domain, lower level domain. It just sort of happens. So bringing this into a spec, trying to give servers the opt-in behavior is never quite. I've never quite understood the rationale or the motivation behind that, and it almost feels simpler to not to just allow it to continue to be a behavior that the client decides on.
At least Chrome's philosophy on this is that we want to encourage this to be like an opt-in behavior, at least in the time between now and when unpartitioned third-party cookies are turned down. And the reason being is that like a lot of servers rely on third-party cookie functionality for various things. Some of that's cross-site tracking, which we're not okay with, but then some of it are some use cases that we are okay with. And in this sort of transitory period where we move off of third-party cookies, we think that like providing this attribute and this opt-in behavior provides developers with an opportunity to kind of migrate their systems over to this partitioned world before we just completely kind of take the rug out from under them and remove unpartitioned third-party cookies. So it's kind of a web compat, I guess, reasoning behind it.
Again, I apologize if I'm not fully understanding, but in terms of compatibility, it feels like there's cases that are going to break. Then if you're expecting third-party cookies that will otherwise work in a partition context and you're not opting into them. So like a server that, does whatever it does in a frame or something and continues to set cookies, get cookies as they would, you partition those, it doesn't know the difference in terms of how it's behaving. But if suddenly it's changed such that you have to opt into partition cookies, then that would, I believe, stop working unless you make the migration. So it feels like that area is not compat, at least not in the way that I think about it. It'd be a breaking change and require software updates to continue working.
I think like kind of at some point there is a breaking change that needs to be made. Either it's like removing third-party cookies entirely or it's just partitioning them by default. So at some point we're going to be breaking sites. I think it's just like a matter of difference on sort of how we want that breakage to occur. I think that like our philosophy is that the server getting the lack of cookie back once we do turn down third-party cookies is a signal that like it's not working as intended, versus having the user agent just sort of like change the behavior of the cookie from underneath the site without really giving it any indication that that's what's going on is like kind of just as bad in our opinion.
Okay. Yeah, I guess I have almost the opposite perspective, that just to have things continue working to the extent that they can without requiring any changes to opt into behavior that should just, yeah, it seems unnecessary and sort of backwards. But maybe I'm off in the weeds here. Kind of feels that way.
There is an explainer, correct?
There is, yes. I can, if you want to come up to me like after this, and if you have any additional questions too, or I can also like send you the link to the explainer where we talk about things in a lot better detail. So yeah, I encourage you to do that.
Okay, thanks.
So Martin Thompson, this has been debated at length in other forums, and the consensus view, I think, was that blocking cookies in these third-party contexts was the desirable outcome. It was not necessarily unanimous that was the outcome. There were a number of reasons, the ones that Dylan articulated, for doing it this way. I also believe that certain other platforms have a little bit of trouble when they tried to implement partitioning properly. And those were limitations around devices not being particularly performant when partitioning was in place. And so, and those were also rooted in the architecture of those systems as well, which I think was a little unfortunate. But ultimately, our experience with partitioning is that it almost completely works. And so you could do without this, but we were sort of in the minority when it came to the discussions there, and we want to respect the consensus process there. And ultimately, this is fine. It's not great, but this is what gets everyone doing partition and state properly. So this is the compromise.
Okay. Well, and you know, we haven't formally adopted anything yet. It's continuing discussion, but it's a good start, I think. Anything else? Okay. Thank you very much. And we're on time too. Next up, we're going to go back to a rearranged agenda and talk about client certs. Brian? I recognize that photo. I thought so.
In London some time ago. Okay, so yeah, client certs. I've only got 5 minutes here, so this will be pretty short. Go to the next slide. I know it takes a minute. Martin, if you want to clear yourself, unless you already have comments. So Mark encouraged us to just focus on issues, questions, etc., and not give any context or anything. It's hard for me, but I take a shot at that in the interest of saving time here. So back in October, we published 03, really relatively minor changes, stating that the certificate chain is presented in the same order as it would be defined in TLS, rather than trying to copy a bunch of language from TLS that is difficult to get right and sort of problematic. Did a bunch of reference updates to things that are now RFCs. Made HTTP semantics a normative reference. Some of the normative informative stuff's a little tricky to get right here, but that one made sense. Mentioned that in the case of the origin server access control decisions, need to be conveyed at the HTTP application layer, either by selecting specific response content or sending a 403 or something, but be pretty clear that we're not trying to invent any sort of cross-layer signaling about error conditions or access control decisions. October 30th, started working group last call. And next slide. I did this sort of last minute because I did have a thing that said there was no open issues. Lucas kindly did a review and put a number of things up here. Thanks, Lucas. There are a number of issues that are open. I don't think any of them are very controversial. We have a little bit of a discussion going about sort of text and what it might look like in the future versus now and context and so forth, but we'll work through that. I saw another one come up, do that as well. But there's, yeah, these are open. I plan to address them. I don't think there's anything of consequence in terms of progressing things along. And we are still in last call for a little while. That's it. That's sort of a boring presentation, but that was, I think, the goal.
Okay.
Thank you.
Any questions, comments? Have people looked at this draft? Martin, you're in the queue. I assume that's from last time. Yeah.
Hello, Lucas. It's here. Yeah, I just had a blast with the draft. Like you say, loads of these are just really low key. There's little things we can pick and tidy up. Would have got caught in some other reviewer. Some of them are editorial, like you say, we disagree. That's okay. You're the editor. If you want to do it that way, that's your discretion. So just wanted to give some kind of contrast and feedback so that in case you didn't think of it that way. So I'm happy however we resolve them.
All right. Thanks for saying that. I didn't think about it that way until you brought it up, but even as I think about it, I still sort of like the background and context, but I'll think about it a little bit. And
So, also in reflection, this is an informational draft.
that is correct.
Yeah, so I think I might have forgotten that. So on reflection, it's having some context is that there might continue to be other drafts other headers that provide this capability.
I'm afraid there almost certainly will be
Yeah.
long into the foreseeable future, as I think this sort of came along a little too late, and so yeah.
And so phrasing it as you've done is kind of reflects the reality of that. This is a way to do it, but it's not the standard because it's
not a standard. Yeah.
So cheers.
Thanks for that.
Jonathan.
Wow, you're really tall. Jonathan Hoyland, Cloudflare. I haven't looked at this draft, so I just looked at it now. But the security considerations is super light. Is that not absolutely terrifying?
I thought they were pretty well done, but I wrote them, so that doesn't necessarily say much. The security considerations are meant to cover I don't know how to answer that, I guess.
It sounds like you might have some suggestions.
Yeah, if there's specific.
So I only looked at the security considerations because I was just curious about how this would work. But how is the proof that the client owns the certificate transferred to the origin in a way that it can tell?
It's not in any way. So there's an expectation that the intermediary, the reverse proxy, is trusted to do this, and it's simply conveying the information to the back end.
In which case, I stand by my previous statement. This is terrifying.
And that's why it's informational.
That is part of why it's informational.
Jonathan, thank you for your offer to contribute to PR.
So actually, to follow up with that statement, this is one of the use cases where this and the signatures draft are intended to work hand in hand, and we actually call this out in the signatures draft because something that a TLS terminating reverse proxy can do with both of these drafts together is send back is to do the TLS validation and then add a signature for this header to the message on the way in that the original client obviously isn't going to add in itself, so that the origin server sitting off in a back end somewhere will be able to check the reverse proxy signature against those inputs, and then that's how that trust is conveyed. It's a transitive process. It requires a lot of out of band configuration and knowledge, but it is one way to string this together.
And you're still sort of taking the reverse proxy's word for it. It just is signing its word versus relying on other mechanisms.
Yeah, so there are all kinds of, obviously you don't want to design protocol standing on one foot, but the easy, or not the easy, there seems to be an obvious way of trying this with sort of exported authenticators or some kind of certificate that's actually bound to TLS connection, and then you just pass through a proof that the terminating proxy controls this particular session, and that particular client had signed that particular session, like to prevent mismatching and swapping. And
so that was discussed some, I think, when we talked about adoption, and the place we ended up at was that this is the intention of this draft is to standardize existing practice within the bounds of described, thank you, existing practice, and align on a single header, because frankly, a lot of reverse proxies and CDNs already do this. And so that's one of the reasons it's informational, because we don't want to put too strong of a recommendation behind that, realizing that there are better solutions. It's just that many felt that this would be an improvement, and it would be more deployable, at least in the medium term.
Thank you.
Thanks for saying what I was trying to say. And
sorry,
in better words. I appreciate that. I was struggling over it, but that's good context, and I think the correct summary of kind of how we got here and what we're trying to accomplish.
Yeah. Anything else? I think we're probably at time on this one. All right, working group last call will continue. If other folks want to take a look and suggest some improvements, we should be at a working group last call pretty soon.
All right, thank you.
Okay. Thank you. Next up, we have, to cap off the day, a presentation about what the wonderful people in Mask are doing and how it may or may not affect the world of HTTP. Sit back, get ready to enjoy a Mask enthusiast at work. David Skenazy.
Hello, hello everyone. David Skenazy, Mask enthusiast. Big surprise, I know. The chairs of HTTP reached out and asked if someone from Mask could just give an update to the HTTP working group about whatever the hell is going on in Mask, because it's totally different people sometimes, mostly the same people, but not everyone knows, and some people might care and they don't know. Next slide, please. Geez, that is slow. So what is MASK? So the acronym is Multiplexed Application Substrate over Quick Encryption, which is quite a mouthful. We came up with the name back in 2018. It was quite unfortunate that there was then a global pandemic for actually more reasons than this, but so now everyone associates it with COVID mask, but that's not what we were going for. Anyway, why do we care? Next slide, please. So in a one-liner sentence, it's we run the internet over HTTP. And if you think that is completely insane, you're probably not wrong. Next slide. So just kind of a quick history lesson here. Back in the good old days of HTTP, before they had this thing called SSL, like bandwidth was expensive and people were building cache servers, especially if they were on other continents where things were really, really far away. Now we call them intermediaries. And then there was the idea, like in enterprise or school networks, that you would intentionally go talk to the intermediary because it's getting stuff to you faster because it's already has it cached. That was, you know, in what we call Web 1.0 these days, because everyone was loading the same thing, so you could cache it and nothing was encrypted. But then eventually SSL happened, and as usual, the security people ruin everything for everyone by making things safer and not working anymore. And so people had deployed these boxes and were saying, no, if you want to reach the internet, you have to go through our HTTP proxy because that reduces our internet bill. But now if you want to do TLS through that, you were stuck. So the connect method for HTTP was invented, so you could run a TCP through and then run your SSL. Everyone's happy again. Fast forward multiple decades, and we eventually remember that the internet is not just TCP. Quick is a thing. Quick becomes standardized at the IETF. Ah, crap. Quick runs over EDP. How could we have predicted this? How do we get that over HTTP. Next slide, please. Q mask. Oh, wow, that is slow. So the idea was, we already can proxy TCP. Turns out that UDP is becoming even more of a thing now. And there are things that are neither TCP nor UDP, like the SCTP people still talk inside IETF, and there are other things. So let's just add a thing for that. So let's just do connect for UDP. So let's call it connect UDP. And then we got to arguing for about 3 years on how exactly to do that. And you end up with a solution that's kind of as simple as you would imagine, where you take the UDP and you put it in the packet and you send it. So we got that published a few months ago, which was really nice, fun time. And because we had to have quite a few bike sheds, we decided to split the baby in half. So there's one RFC for proxying UDP and HTTP, and one RFC that it depends on, which is HTTP datagrams, and also the capsule protocol, because we couldn't come up with a better name than capsule. So HTTP datagrams, the idea is that in addition to your regular HTTP stream, which is a concept that we've had since HTTP2, you can send datagrams for little bits of data, and that's really handy if you want to send UDP. You just put them in there. The really reason for that this exists is that you can then map it to a quick datagram frame, which doesn't get retransmitted, which is exactly what you want for Connect UDP, because if you put it inside the stream, you'd get bad performance. And the capsule protocol that I mentioned was something that we thought would be useful. It's useful for like HTTP 1 and 2, where you don't have the quick datagram frame. And it's also useful for other things. Or more, we wanted it for that, and we said, well, let's toss in a TLV so it's extensible. We have some use cases for it. So it allows you to send something all the way through all the intermediaries reliably. And so those were our first deliverables. The RFC shipped a few months ago. We are working now on proxying IP and HTTP. We had a whole nice fun detour on writing a requirements document for that first, which I was kind of annoyed at Mark when he suggested that at that first. But he made a point that like, oh, you're not actually all agreeing on what you mean by proxying IP, and you were right. So we ended up arguing on the requirements document instead of arguing on the discussion, on the solution document. But at least when we went to build the solution, we knew what we were going to build. So that's been taken care of. We're building the solution, and we're pretty close to done. So we'll be discussing this at the MASC meeting, which is sometime this week. Come if you're interested, but we're pretty close to done. Next slide, please. So why would you want MASC? One of the things we discussed at the beginning of the effort was, do we want this to be over HTTP? We all agreed that it had to be on Quick, because Quick is the best thing ever. But then do we put it over HTTP3 or other things? And we're thinking, well, sometimes it's nice to be able to run over networks that block UDP. So putting it over HTTP means you have access to HTTP 1 and 2. I really like the fact that if you put it over HTTP, then it starts looking like web traffic. So it makes it really harder to block. So now you have a VPN that looks like web traffic. Hard to censor. I like that. Don't say that. Some people don't like that. Another part that I hadn't thought of at all, but that we realized was companies like Google have already put in a lot of effort in having a really good HTTP server. And so a quick stack that's efficient and security reviewed, and HTTP load balancers. And if you build this over HTTP, you kind of get to reuse all of this for free. So we end up like in places where like, oh, can we use IPsec? And people were like, no, we'd have to review that whole new stack and we don't want to. Can you just find a way to make it work over Quick? And then there's a fun story there where Alex and others back at Google actually implemented a VPN over Quick way before the MASC effort and was kind of the catalyst for the whole thing. And then we are closing the loop on making that use MASC now, which is fun. And then when we built this, folks that like to use buzzwords like zero trust and other things that and serverless and things that I don't understand said, oh, this is great. Can I use this too? And they were pretty much the problem they had was they had VMs in the cloud somewhere that needed to talk to each other, but there were HTTP load balancers in the middle and they wanted magic crypto. And we said, well, actually, they had built something using Connect because that was the simplest thing for them. And then they had a customer who wanted UDP. So boom, this actually works for there. Like reusing stuff is useful. Next slide. So where are we going from here? The mask working group was very tightly scoped to make sure we didn't get too distracted and to kind of get us to focus on shipping Connect UDP and Connect IP. But now that we're almost done with that, we're talking about a scoped rechartering for future things. So that's also on our agenda. I don't think the current plan, from what I hear for our ISG overlords, is that they don't want a mask maintenance working group that lasts forever. We'll just recharter for a few scoped extensions, do those, and then potentially shut it down and say future things happen in the HTTP working group. We'll have to discuss those things. It's not entirely figured out, but I guess that's what's going to happen. But what are the extensions that we've been discussing that might happen before then? So first, we have extensions to Connect UDP. So Connect UDP, similar to Connect, kind of gives you a connected 5-tuple. But if you want to do something like WebRTC, where you're talking to multiple hosts, your one proxy, it doesn't work for that. So we have a little extension for doing that. We have an extension for doing quick over Connect UDP. You can run quick over Connect UDP non-extended, but Tommy had some clever ideas on how you can optimize that and make it better. We have extensions kind of at the HTTP datagram layer. Marcus and Ericsson folks have an idea for adding sequence numbers to catch reordering when they're doing multipath quick. There's an extension from Ben about having a way to figure out your path MTU through the entire chain between your client and your endpoint. So that way it makes it easier to run protocols, unlike Quick, that can't do it themselves. Lucas has a draft about priorities in HTTP datagrams that he's very excited about. Next slide, please. And we have some generic, like other HTTP extensions that the authors were thinking, like mainly in the context of mask, but could also be applicable to other HTTP use cases. So we haven't selected the venue. Like all of this future work that I'm talking about is individual drafts. So Tommy has something about sending more DNS information using the recently published proxy status header. And Ben has documents on describing what mask services an HTTP origin has and on modernizing Connect itself. Next slide. All right, so we are meeting this week on Wednesday. We have a mailing list, a GitHub, like all the cool kids. If any of this sounds interesting to you, please show up, please come, and we're happy to bike shed on all the things as we always do. That's it. Any questions?
Any questions? This is mostly informational, and then some of the folks are already very familiar with this. We just thought it'd be good to make sure that everybody in the working group here was aware of what was happening over there, especially as you get a little bit closer to stuff that happens inside of HTTP. So thank you very much for that. Really appreciate it. And with that, I think we're done for today. Let's check the agenda. Yes, we are. Fantastic. Sorry?
I wouldn't mind doing my presentation from Friday today if we have spare time.
Ooh, what time is it? Well, we have 25 minutes. Your presentation from Friday being which one?
Unprompted authentication.
Unprompted. In principle, I don't have a problem with that. I'm just worried that somebody who was expecting it on Friday might be a little surprised by that. But of course, there is always the mailing list where if we do adopt something or whatever, it'll need consensus. So as long as whatever happens goes to the mailing list, I think we'll be up.
Which it would, yeah.
Yeah. I think so, sure.
Any objections to that?
Tommy, are you still awake?
I am. I'm hanging in there. Got my coffee. Yeah, I think that sounds fine. Yeah.
Okay.
Go for it.
Thank you.
Reordering is something we're still a little unfamiliar here in HTTP land, so you know.
I know.
We have a mask for that. There's a better way to phrase that, I'm sure. All right. Hello. It's me again. David Skenazy, HTTP enthusiast. So this is a draft that was initially part of the original mask proposal, so this is actually not a bad segue, and people gave me very good advice at the beginning that you don't merge everything into a big castle in the sky, otherwise it doesn't work. You split it up into small bits that make sense. And so this was one of those that then went dormant as we were all focusing on mask itself, and now people reached out that were interested in it, and I'm trying to resurrect it and see where we want to go with it. So this, now we have multiple co-authors. This work is joined with David Oliver, who's I think attending virtually this time, and Jonathan, who's right there. Next slide, please. So the draft initially was called Transport Authentication, and the reason for that was that the original mask proposal was, I think the term is monstrosity in terms of HTTP semantics, because it took over the whole connection and did things that were very evil by HTTP standards. And so the new version of mask, as we talked about, fits into HTTP semantics. But because of this, the old version needed a way to authenticate the whole transport. Now we don't need that anymore. So the draft has been kind of completely rewritten. The cryptography bits are still in there, but now it fits in HTTP semantics similar to how mask does. Next slide. So the motivation we have is we want the client to authenticate to the server, or to the origin, as is commonly done with HTTP authentication. We want to use asymmetric cryptography because there are some use cases where you want to be able to share the access list with their public keys across multiple origins that don't necessarily trust each other, and you want to avoid having an origin be able to impersonate one of the clients. And then the third requirement is we want the server to hide the fact that it serves authenticated resources. So what I mean by that is if you try to get this resource, you don't want a server to send you a 401. And the reason for that is, let's say you have your personal website, but you want to offer some mask services to authenticated clients. You don't want someone to be able to probe your server and go, oh, no, that offers mask. That's blocked on my network. Bang, bang. So those are the three, I'm going to dive a bit into the solution space in this presentation, but the goal or the interest of this draft is really to see if there is interest in those requirements and that motivation, because everything of the solution is completely up for debate or any discussion. This is what I care about personally with this proposal. Next slide.
Just to be clear, your third requirement there is that the server hides the fact that it can serve authenticated resources?
Yes.
Not that it is serving.
So yeah, let me rephrase that. I guess that's not very well written. Let's say that the server offers a resource to only authenticated clients. That's a common thing. And an unauthenticated client must not be able to find out whether that's the case or not. So it can't probe the server to find out that the resource is there, you're just not allowed to see it.
Okay. I'm thinking about the very header, but okay, go on.
About what?
The very header.
Yeah. So why don't we already have this in our very large suite of HTTP authentication methods? So if you're doing cryptography and you're using a signature, you need something to sign, and you need that to be fresh. Otherwise, things are replayable. So in common protocols today, the way we do that is the server sends a nonce, the client signs that nonce, sends the signature back, and the server goes, great, that's fresh. But that breaks our requirement of the server not letting on that it does this, because if it sends a nonce, you go, oh, I got a nonce from you. I know you support this scheme. So HOBA is a means that does that. For example, that's already standardized, but that leaks the fact that the server does this. Next slide, please. So the idea we had, where I think the clever part came from Chris Wood, I think, but anyway, is if you use TLS key exporters, that gives you a nonce because both the client and server have fed information into the TLS key exchange. So you know that a key exporter is fresh. I'm blanking on the name. Channel binding used that as well, but we're not doing channel binding. Very different, but just that same idea of using a key exporter, not to generate a key, but just to use it as a nonce. So that doesn't link any information because any side can export the key locally, and it can't be replayed either. MT?
I don't know if you've thought about this one, but it's possible that in certain contexts, say like web browsers, an adversary might be in a position to, for example, make requests. And this only prevents the authenticator from being moved to another connection. It doesn't prevent it from being reused on the same connection.
So that's true, but you still need the private key to be able to.
You don't need the private key, you just need to see the output. And if you can copy the output, you get to.
So how could you get access to that output? Or sorry, what output? So the headers that you're sending?
This is somewhat theoretical, of course, but if the headers on one request leak in some way.
Oh, I see what you mean.
Reused on that same connection again.
So this is the attack. We discussed this at the last IETF, and so Jonathan and I thought about it for a bit, and that's a real attack. If you leak that you sent a header with this on one request, you could put that on another request, but the threat model there is an attacker that is already like inside the TLS, and so we decided like that wasn't practical in practice. So we added a paragraph to security considerations saying that that was out of scope. But it's a real attack.
As long as you've thought of it, that's all. It just occurred to me.
Yep. No. We thought about it. Like we could, if we wanted to, solve it by putting something like the stream. Well, the stream ID would be gross, but something that's unique. It's not the end of the world, but like we thought that in practice it wasn't a problem. So we document that if this is part of your threat model, then don't use this.
You could bind to things in the request so that it's not portable between requests. For instance, the URL. I don't want to pull too much in, but
yeah, no, we could do something like that.
Narrow the scope of reuse. I don't know that that's worthwhile.
Yeah, yeah. So the advantage if you have the same thing is that then it gets compressed by HPAC or QPAC, and we thought that was a nicer benefit than this attack. I mean, that's totally. We can go either way. Both work. It's a security versus performance trade-off, as we often have. Alex,
sorry, is there clarification or
follow up to the discussion?
Okay, if we can quickly.
Yeah, I Alex Shanowski, Google. I just wanted to add that I also previously brought up a similar thing around the fact that this was a connection-oriented export, and it really did weird things around streams. So like I think if we incorporated Martin's idea about making it be request or stream oriented somehow, it would also make it clearer that this wasn't a shared resource. So maybe somewhat repeatable, but not 100% repeatable. Like URL is definitely a nice one that would still get you some of the compression.
Yeah, we can figure that out. Cool. Next slide, please. Oh boy, come on. There we go. So this is kind of a description of the solution. We renamed the draft to unprompted authentication. I really wanted to call it masked authentication, but I was told that wasn't funny. So we went with this. At least it's clear about what it is. The server doesn't tell the client that it needs to authenticate. The client does it without being prompted. And it authenticates a single request. And you send what kind of authentication, so signature or HMAC, and then which algorithm, like for a signature algorithm or hash algorithm you're using. So initially we used OIDs and MT found that gross. So I grabbed something from the INA registry and I managed to get that wrong too, but that's fixable. I got some good comments there in the GitHub. That's easily fixed. And then, a username and the proof, base64 encoded. Next slide, please.
But that's not a structured header, is it?
I have a slide for that. It is, unless I messed it up.
Well, that first, you messed it up.
I'll get back to that. In term, like we kind of discussed this with the client certs idea. Similarly, this can't be transparently forwarded because it pertains to the TLS connection. So the intermediary checks it and then tells upstream what the result was. That part we've declared it out of scope. You could build something like the previous presentation if we wanted to, but I don't have a use case for that. So we decided it's out of scope of this draft for now, and it can be built separately. Next slide. So what we changed since last time, because we got some pretty good feedback when we presented this. So we renamed the draft, we removed the OIDs, we added the security concerns to discuss this, the issue that we just talked about. Jonathan joined as co-author to make sure that I stopped shooting my toes off security-wise. And we switched to structured fields. Maybe I got it wrong. Again, I'm an HTTP enthusiast, not an expert, but I tried to switch to structured fields because I hear they're all the rage, and did a bunch of editorial work to try to make the document better. Next slide, please. So we have an independent implementation by the Guardian project. So multiple entities kind of interested in this. We're wondering, is the HTTPBIS working group interested in seeing this progress here? Should we take it elsewhere? What do people think? Is this completely insane? Is this a good idea? Do other people find it useful? Any thoughts, questions? This is my last slide, so come on up. Mike.
Mike Bishop, I do think it's useful. I feel like you're kind of re-implementing some of what's already in exported authenticators. So you might be able to just get one of those and then base64 encode it. But I don't know. I don't know what the gap is on that, but it might be something to explore.
So exported authenticators don't have that property. I think from memory, and someone can correct me if I'm wrong, you need like that kind of exchange that kind of leaks that the server does this. Yeah.
Okay, it is bound to a request then. Okay. All right. So building many of the same mechanics without binding to that request should be fine.
Yeah. At the end of the day, it's not horribly dissimilar. Yeah.
Yeah. But more broadly written, yes, I think this is of interest. It's a useful property, and there are already HTTP servers that will refuse to admit a resource exists unless you're authenticated. They just have some other endpoint that you auth to first. So this would be a nice improvement in security for them.
Thank you. Ben.
Hi, sorry, my network's a little unstable. So I definitely want this. I've even sort of been involved with deploying a system that attempts to achieve this property. But I still don't understand the use case that motivates this design. Thanks for helping me understand a bigger piece of it. I'm closer, but the thing that I'm most confused about is this. If we assume that there is no indication that a given origin supports this, then a client presumably must be configured out of band with information to know that it can use this mechanism with this origin. But any mechanism that could configure this client to know that about this origin could have just provided this client with a per origin symmetric secret, a password, that would allow that the client would send unprompted authentication, yes, to that server. But this would not authenticate the client, right? This would just reveal the client as being among the set of clients that knows this information about the server. And then the server can respond with a challenge, and we can go through standard challenge response authentication. So why didn't you do that?
So it's the general question about shared cryptography versus or symmetric cryptography with versus asymmetric cryptography. And yeah, pretty much almost everything that's done with asymmetric, you could do it with symmetric and N keys, but then you kind of have to tie the list of potential origins with the keys, and you get like a bad scaling problem. Whereas here you can get the keys once and then later over time get the origin simpler. So it gives you like more flexibility. I mean, there's
Yeah, I'm not convinced that it actually provides that kind of efficiency improvement in this case. Because again, you need to be provisioned out of band with this information about each origin that you could potentially contact. And so you already have, and the clients are already being provided with order N information here. Adding passwords on top of that doesn't increase the order of information that's required to be shared with clients. And if you want this kind of shared cross-origin authentication of clients, where clients use a single credential across all of these origins, you can still do that. You no longer have to do it within an unprompted context. For example, you can do it in a HOBA context, and then you don't have to worry about this thing of like, I'm bound to the TLS session, I can't traverse intermediaries, I'm doing channel binding.
Yeah, that really depends on your use case. It sounds like you don't need the symmetric part here. Thank you.
Well, so I'm telling you that you don't need it. Like Guardian Project, I'm very familiar with their use case. They do not, like, the system I'm describing is their system. Like that's how it already works. That's how the bridge distribution system is already defined. So I think, look, I think if there's an advantage here, I could argue that it saves a round trip. Like it avoids the need to sort of pre-authenticate and then actually authenticate as a second step. You can do it in one go. Maybe that's important in some use case, but I'm not actually aware of a use case where that efficiency gain would matter. And so I think that basically there's a more flexible, less complicated solution here. I think we should solve the problem. But I'd like to see this a little more strongly motivated for this design.
Fair enough. Yeah, I mean, complexity is in the eye of the beholder, so I think we can agree to disagree on that one.
Well, okay, yes, but like the working group work, has to ultimately proceed by consensus about this. So that's it's also for the working group to consider whether this is the right approach.
All right.
Okay, thank you.
So let's hear some other opinions then. Kyle?
Kyle Nokritz. It's not completely clear to me what is being done here that couldn't be done with token binding.
Sorry, can you get a bit closer to the mic, please?
Yeah, what is being done here that couldn't be done with token binding?
So from memory, it's been a while since I've I've looked into that. Well, I mean, one problem is it's more complicated machinery, and it's at the TLS layer. Well, of course, it's at the TLS layer, but I don't know if it has the property of client speaks first or directly tied to a request.
So the standard way of doing token binding does involve a negotiation at the TLS layer, but I think that could be omitted and get the property that you have here in effectively the same way, where the client would derive a EKM from the TLS connection and then create a signature of it, put it in the token binding header.
So I would have to double check. From memory, there was a lot more involved in token binding and the interactions with the TLS layer that made it quite a more complicated beast, and would be harder to just have like a little token that you send. That's a reasonable question. I can give you let me do some research. I can give you a better answer because it's been a while since I've looked into token binding.
Anyone else? I'm kind of wondering if we could get a sense of the room of who's interested in continuing the discussion.
No, that would be great.
Yeah, so without making any commitments or saying that, yes, we'll adopt something or that you're going to implement it, just a show of hands online as well as in the room. I don't know how it works online, but we'll sort stuff out. Who's interested in continuing this this discussion? That there might be something here. Okay. So I see a smattering of hands in the room, including some implementers. Online, I'm sorry, this big sign here says, please do not touch. So.
Oh, because you're presenting full screen.
Yeah. Oh, that's what's happened. Okay, so. I guess they don't have a way just to get in the queue if you're interested and you're online, and then get out of the queue. Let's do it that way. Just queue yourself. We're getting +1s in the chat. That's good. And I see a few people in the queue. That's helpful information. We're gonna adapt the tools. We're gonna pay some cow
Wait, so
pads.
we have. Oh, it's funny. You could see the people in the queue then falling down the infinity well.
Yes. Don't look too hard. Yeah. Okay. All right. I think that's good information. It sounds like there's at least some interest in continuing the discussion. So let's do that.
Cool. What would you like from the authors? Are we at the level of an adoption call? Are we not there yet?
I don't. I'll talk to Tommy. I suspect we're not quite there yet, but maybe a little more on list discussion, some exploring of the issues. Like Ben said, making sure we understand the use case and why this solution is the right general starting point for that.
Sounds great.
Good. Yeah. Yeah.
Awesome. If I'll see you all on the list on this topic if you're interested.
One more question for you, actually. What's your sense of urgency around this?
Not really. I mean, it will be nice because we have a use case. I mean, you can ship thing without having a standard, but it will be a nice bow tie to the mask story as well to have all these things like wrapped up. So,
okay. Yeah. All right. Thank you. And we've got 5 minutes left. So unless we have any other business, I think we can close for today, and we'll see everyone on Friday. Thank you.
Great presentations. We've never met in person. I'm Tommy. So, I feel like there's a lot of potential good behind it. I don't know that I understand. I too, it does when you present it like so. Yeah, token binding, got it. And it isn't really quantified. Like the first proposal of this was. Oh, okay. I have this memory all the time. I don't remember what it was. Yeah, 4 years, I believe you. It seems like there could be some interesting cases here. Like, I haven't thought this through, it might be idiotic, but as you were presenting, I was thinking about what's going to be talked about tomorrow, which is the protest in Iran. That you could make public resources available that look like they're open, not be blocked, that would not cause for authentication, that could be an input using this kind of mechanism that would provide some protection to whoever that's actually it's weird. I feel like with that like I literally my first proposal I got booed up. Times have changed. Right? It's still phrase it correctly. Exactly. Like part of the